Hi everyone, welcome to CodAffection. It's been few weeks since my last upload. I have been busy working on a comprehensive ASP.NET Core course. I'm really excited to share more updates in the coming weeks. The course should be ready in about 2 to 3 months, so I hope you will forgive my absence. Now, in this video, we will walk you through implementing user authentication and authorization in ASP.NET Core Web API using ASP.NET Core Identity. If you have been following our channel, you may have already seen the step-by-step series discussing the same topic. This video brings all those parts together into one complete guide. We will cover everything from setting up user registration and login to configure JWT authentication and authorization with role, claim, and policy. Plus, we have built a client-side application in Angular to interact with the API created in this video, which we will be uploading in next schedule. Looking ahead, we also plan to add a React frontend for this web API in a future video. The web API project we built in this video will be available on GitHub. Each section has its own repository, allowing you to track incremental changes throughout the project. So without further ado, let's get started with creating the web API project inside this Visual Studio 2022. So first of all, create a new project. Select this template ASP.NET Core Web API. I will name this project as Auth API. Click on Next. Then select the latest installed .NET version. Then I will keep this authentication type as none so that you will know how to implement it from scratch. Now since we have a demo project here, I will uncheck this HTTPS configuration. Then I will keep this feature OpenAPI support as it is. This feature allows us to make use of the Swagger tools for testing the various endpoints that we create inside the web API project. Now click on Create. So here we have the brand new web API project. Before we go any further with ASP.NET Core Identity inside this project, first of all I want to talk about Identity and Access Management, abbreviated as IAM. Throughout this series, I will squeeze in as much as prerequisites like this to make you familiar and comfortable with ASP.NET Core Identity. So in short, IAM ensures the right people or machine or software components get access to the right resources at right time. Now, when it comes to authentication or authorization, it might not be always a person trying to access a secured or protected resource. It could be machines, for example robots, and it can also be a software component. Now assume that you have a client-side app in Angular or React, and inside that app, say you want to retrieve all of the Facebook groups that a particular FP user has joined. For that, first of all, this client-side app must be authenticated to the Facebook developer auth system. In this given context, instead of a person, we have a software component that is trying to access the Facebook API. Instead of a normal FP user credentials like password with email or mobile number, the software component should be passing a different credentials which is first registered into the Facebook developer system. So in this given example, the client-side app acts as a software component. So in short, the party that is trying to access the protected resource could be anything in this range: people, machines, or software components. So IAM ensures that the right party get access to the right resources at right time. In brief, first of all, the party must prove that who they are or what they claim to be. A process in which they have to prove they are an insider. This is what we call authentication. More about that will be discussed in next section. This process in layman term we often call as login or sign-in operation. Now let's go ahead with the next step. Even when a party is successfully authenticated into the system, proving that they are an insider doesn't mean that they have the full access to consume the entire resources inside the protected system. The party could be allowed or denied to access certain resources inside the system. Now, this process is called as authorization. We'll deal with that in section 4 of this video. So a solution that fulfills these requirements is globally known as Identity and Access Management, in short IAM. For .NET applications, these are the available identity management solutions. Among them, ASP.NET Core Identity is the commonly used identity management solution for .NET Core applications. Now let's get straight into ASP.NET Core Identity. Now before getting started, I just want to let you know that the official documentation of ASP.NET Core Identity could be seen under this ASP.NET Core documentation inside this section, Security and Identity. And make sure to select the right .NET version from this dropdown. You could see the link of this official documentation inside the video description along with other important resources that I have referenced for this entire series. Rest of the prerequisites could be discussed when the right time comes. So with that being said, back to the Web API project, and let's look what we have inside this default Web API project. So everything starts with this Program.cs file. So first of all, we have a builder object returned from invoking this method createBuilder from this web application class. Inside the builder object, we have this service collection. Into that, we'll be adding services that we need inside this Web API project. And from the same builder object, we have invoked this build to return the app object, which is then used for configuring the services that we have added into the service collection here. Okay, you could verify that here. As you can see into this service collection, first of all, we have added the controllers that transform this application into a Web API project. Otherwise, this would be a plain C# console application. And then with this app object, we can configure the services that we have added here. So for example, we have called this method map controllers so that all of the endpoints inside the various web methods inside this application will be configured into this project. Similarly, we have added the services for the Swagger UI here, and the same is configured here. Along with all of these methods, we have invoked this method use authorization. We'll talk about that later. And finally, with the execution of this run method, the entire application will be made available to accept the incoming request. So that's all we have inside this project. Now it's time to add ASP.NET Core Identity into this project. We have already discussed what is an identity access management and what it does. So the same is applicable to ASP.NET Core Identity also. Now let's be specific about what it does. ASP.NET Core Identity includes APIs, UI, and backend database configuration. So basically it allows us to manage user identities, storing user credentials, and granting or revoking permissions. And we are planning to implement these features in this video series. Now as part of this first video, we'll be creating user identities as part of user registration. Now along with these primary requirements, it supports external logins, two-factor authentication, password management, account lockout and reactivation, and support for authenticator apps. So all of these features are made available by ASP.NET Core Identity to the outside world through the APIs here. We just have to consume them with the required data passed to it, which are basically Web API methods. Now when it comes to a web application MVC, it also provides the front end with Razor pages, which I have already discussed in one of my previous video. Link will be there inside the video description under the heading related videos. And finally, we have the backend database configuration, which is basically Entity Framework Core models. So throughout this series, we'll be discussing how to make use of these services provided by ASP.NET Core and how to customize them as per our requirement to implement all of these features here. Now it would be more helpful if we understood the architecture of ASP.NET Core Identity in brief. We'll come to that in a bit. Before that, let's install the required NuGet packages into this Web API here. For that, right-click on this project, then Manage NuGet Packages. Then inside this Browse tab, search for this package, Microsoft ASP.NET Core Identity Entity Framework Core. Throughout this series, the install NuGet packages name will be there inside the video description along with other helpful instructions. You just have to copy paste from there. Now let's install this Identity Entity Framework Core package. Now since we are going to use SQL Server for this project, we have to install the corresponding Entity Framework package. which is EntityFrameworkCore.SqlServer. Let's install this. Now finally, in order to execute the migration commands, we have to install this package EntityFrameworkCore.Tools. So these are the NuGet packages to get started with ASP.NET Core Identity. Now let's add the corresponding services into this Program.cs file. Like this default project added the service for Web API controls. Now before doing that, let's get familiar with the architecture of ASP.NET Core Identity. So first of all, we have the data source layer for storing the data related to the entities inside the framework. In our project, it would be a SQL Server DB. Then we have data access layer. By default, it would be Entity Framework Core. And then just above that, we have identity store. It defines the structure and relation between various entities inside the identity solution. You could think of them as entity framework models, like users, rows, etc. All of them defines the ultimate structure of the table that is going to be created inside the data source. And then we have identity manager. For each entity we have inside the solution, such as user or rows, we have corresponding managers like user manager, role manager. So basically they consist of methods or handlers to implement the features that we talked about, like creating users, authenticating, authorizing users, etc. and etc. So these are the two layers that comes from ASP.NET Core Identity. Now in order to make use of them inside our ASP.NET Core Web API, we just have to add the corresponding services into our Web API project. So here we go, builder.services. First of all, we have to add this identity API endpoints. So this will add the various API endpoints from the identity core, which are handlers to implement various features that we talked about. Now while invoking this method, we have to pass the model class corresponding to the user entity. So that will be identity user. So by default, this is the class identity user, which defines what all things we need inside the entity user. So here you could see the default properties inside the user entity. We'll customize that in a bit. So first service is added here. So the service that we have just added is corresponding to this identity manager and the corresponding exposed Web API methods. Now let's add identity store. Let me zoom in a bit. For that, we can invoke this method add entity framework store. So these are the two services that we have to add to make use of the identity core. Now while invoking this method, we have to pass the class corresponding to the DB context that we are going to use to interact with the DB, which we have not yet created. So let me create a new folder called models. Inside that, we can have this class app DB context. Normally, in order to define a DB context class, we inherit this entity framework class DB context. In case of identity core or ASP.NET Core Identity, we have to make use of this DB context class identity DB context. Now this becomes a DB context class. Now let me copy this and let's pass the same here. So here we have done with adding services from ASP.NET Core Identity into this Web API project. Now using the model classes that we have inside this identity store, let's create the actual physical DB inside the SQL Server. For that, we can just continue with the DB context class that we have just created. Now first of all, let's add the constructor like we used to add in any entity framework called DB context. Now here we have the corresponding parameter DB context options. Now we have to specify the DB context class as app DB context. Let's name this parameter as options. Now along with this constructor, we also have to invoke the base constructor, which is the constructor that we have inside this parent class here. For that, we can do this base then options. Now in order to create the physical DB with the existing default entities inside identity core, we have to do the migration. Now by the way, these are the entities that we have inside ASP.NET Core Identity. For each of these entities, you could expect a SQL Server table. Now before doing the migration, we have to inject an instance of this DB context class inside this Program.cs file. So here we have the service. From that we can call this method add DB context. Now if you don't know how dependency injection work, we can explain that in brief in a bit. Basically it is a process of creating an instance of this passed class here. So in order to create this instance, we have to pass the argument corresponding to this constructor parameter here. So basically it is expecting a DB provider based on the DB that we are using. So we'll pass the argument using this lambda expression. All we have to do is from these options, we have to call the method corresponding to the DB provider that we are using. Since we are using SQL Server inside this project, we can invoke this method use SQL Server. Into that we have to pass the corresponding DB connection string. So first of all we have to save that into this AppSetting.json file here. So here we go, connection strings. Inside that we'll have this key dev db. So this connection string is only for the development environment. So first of all we have the SQL Server instance name, and we have the DB name which is auth-ecdb, and then we have these options. First of all, trusted connection is set as true. Now in order to enable the encryption, we have set this option as true. Now finally, in order to execute multiple query batches simultaneously, we have set this option multiple active result sets. So that's all we have inside my DB connection string. Now let's pass this same into this use SQL Server method. In order to access the data that we have stored inside this app settings, we could make use of the builder object like this, builder.configuration. From that we can invoke this method get connection string. Into that we can pass the name that we have given for the connection string. Now we are ready for DB migration. Now before getting into that, let me briefly explain how dependency injection works in ASP.NET Core. So here we have injected an instance of this app DB context class, and here we have the default controller inside this app weather forecast. Inside that you could see this default web API method for a get request. The instance of this class here, this controller class, will not be created as by manually. It will be automatically created by the ASP.NET Core framework when a request reaches up to this web API method here. So during the creation of such instances, if the corresponding class constructor is having a parameter which is of the type that we have injected here, then a corresponding instance will be assigned to the constructor parameter that we have here. Say for example, for this constructor, we have a parameter of the type appDBContext. When an instance of this controller class is created, an instance of this appDBContext will be passed because of this dependency injection here. We don't have to create the instance manually. So that's how dependency injection works. Now let's go ahead with DB migration. Before that, build the project. Make sure that there is no error. See, here we have a successful build. Now all we have to do is open the package manager console, which in my case it is inside this bottom portion of the Visual Studio. If you can't see it, select the project, then go to Tools, then NuGet Package Manager, then Package Manager Console. Now for DB migration, first of all we have to execute this command add migration, then provide a name, let it be initial migration, hit enter. As a result of this command execution, here we have a new folder called migrations. Inside that you could see the C# file with respective SQL Server commands which is to be executed to create the actual physical DB. Now in order to create the actual physical DB, we have to execute this second command update database. So here we have successfully done with the migration. If there is any problem in connecting with the physical DB, you could expect an error while executing this second command. So if there is any error, please recheck your DB connection string. Now in order to work with the database, I will be using the SQL Server Management Studio. Let's check whether the actual physical DB is created or not. So here we have the new DB. Inside that you could see the tables corresponding to the entities that we have inside ASP.NET Core Identity. So these are the tables corresponding to the default entity framework core models that we have inside ASP.NET Core Identity. By default, all of these tables name will be prefixed with ASP.NET. Now let's check what are these tables stands for. So first of all, we have the table or entity user, which is having these properties or corresponding columns like username, email, password, phone number, etc. Then we have this role entity consisting of the collections of roles that we have inside our project, like admin, accountant, HR, etc. and etc. Then we have this user role, which is saying what are the roles assigned to a particular user. Now you can see this entity user claim and role claim. These are the additional informations that we can add to a user or a role. You will understand it better in the third video of this series. And then we have this user token representing the token assigned to a particular user. This will be helpful when it comes to our token authentication. What is meant by token authentication will be discussed in next video. And finally, we have user logins. It represents or store information about user logins, especially when it comes to external logins like Google, Facebook, etc. So that's all about the DB part to get started with this project. Now back to the Program.cs file again. So these are the services that we have added from Identity Core, including the various endpoints to make use of the handlers inside the framework. In order to add the respective routes into this application, we have to configure this app object like this, app dot. We have to call this method map identity API. Here we have to specify the model class that we use for the entity user. So by default that will be identity user. Now let's run this app to see the various endpoints exposed from ASP.NET Core Identity. So these are the various web API methods or endpoints that we can make use of to implement the identity solution inside our project. Now the URL to this web API method will be like this, localhost, then this port number /register. Now since we are inside a .NET Core Web API, we have to prefix API just before this endpoint here. So API /register, API /login. In order to do that, we can do this just before mapping the identity endpoints. We can invoke this method map group, and inside that we can pass this /API. Let's build this project. See, that's it. Now in order to register a user, we have to consume this post web API method here, API /register. And it is expecting these data like email and password. Now if you only need these two information for creating a new user, you can make use of this post web API method. But in this tutorial, we also want to show you how to customize the identity as per your requirement. So in case of this user registration, along with these two informations, we also need the full name of the user. For that, back to the project. Now we'll create a new model class. I will name it as app user. Now we have to inherit this class from the identity model identity user. So along with the properties that is there inside this model class, we have to add this extra property for full name. Now let's specify the data type corresponding to the SQL Server column. So here we have the attribute column. Into that we can pass this type name. Let it be nvoc 150. Now you could see this green squiggly line here saying a non-nullable property must contain a non-null value. In order to disable this warning, just place the cursor inside this property, then expand this drop down, suppress or configure issues, configure severity, click on silent. Now ASP.NET Identity recommends adding the data attribute personal data to all the properties which are related to personal information of the user. Now let's copy this user class from here and let's update the same wherever we have used identity user so far inside this project. You could see all of them inside this Program.cs file. First of all, we have the mapping for the identity endpoints, and then we have mentioned the same while adding the services for API endpoints. Okay, Let me save this. Let's build this project. Build is successful. Now let's do the DB migration again for the newly created property here, full name. So open Package Manager console. First of all, execute this command add migration. I will name it as name is added in user entity. Hit enter. Finally, we have to execute this command update database. Sorry, we forgot the important step, which is adding a reference of this app user class into this DB context class here. Because when it comes to Entity Framework Core, everything will get connected through this DB context class. So if a new model class is added to the project and which is not added here, and then it won't be considered in future DB migrations. So all we have to do is just define this property dbSet for the model class app user. Now this property can be used for interacting with the corresponding table. So I will name this property as app users. Let's save this back to Package Manager. Let's re-execute the commands. I will name this migration as second try. Update the database. Back to the Management Studio. Refresh the DB. Let's expand the columns of this user table. So here is the new column, full name. Now during the user registration process, along with these details, we also have to pass the full name. So instead of using this default web API method, we're gonna create a new post web API method for user registration. That we can do inside the Program.cs file itself. Later we can organize everything into respective files and folders. Instead of conventional controls like this, we're gonna use minimal API controllers inside this project. With this new minimal approach, it is really easy to create new web API methods and way more satisfying than conventional controls. So in order to create a post web API method, all we have to do is from this app object, we just need to call this method map post. So this becomes a post web API method. Now as a first argument, we will pass the URL. It will be API/sign up. And here we have the corresponding callback to handle this request. As per the current setup of Identity Core, there is no straightforward method to reuse this URL. And with the current version of the framework, we can't extend already existing implementation of the verb methods from Identity API. Could be made available in upcoming versions. So that's why we have created a separate URL here. Now talking about the actual implementation. Hope you know that ASP.NET Core Identity is an open source project. You could see the actual source code inside the GitHub repository here. And if you want to see the actual implementation or source code of these identity web methods inside this project, you can search for this file, Identity API Endpoint Route Builder Extensions. Inside that, you could see the actual implementation of the web API methods that is available inside the project by default. So for example, if you want to see the actual implementation of the web API method, which is responsible for the registration of a user, here is the web API method. And for login, you could see the post web API method here. So like that, most of the web API methods that is exposed from the identity solution by default could be seen inside this file. Back to the topic. Now let's handle this post request inside this callback. First of all, we have this parameter user manager. Along with this manager, we also have to pass the model class for the user entity. That will be the new class that we have created, app user. We'll name this parameter as user manager. Now we need a second parameter to accept the user information that is passed through the body of this request. For that, I'm going to define a class like this, user registration model, after executing or invoking this run method here. Don't worry, we will organize the Program.cs file in an upcoming section. So this class represents the properties that we expect through this post web API method, email, password, and full name. Now let's add the second parameter accordingly. From the body of this request, we expect the properties that we have inside this class, user registration model, and we'll name this parameter as user registration model. From where do we get an instance of this user manager class? Now we need this user manager to do any operation related to user. In this case, we have to create a new user. We have already seen this class user manager while explaining the structure of the identity solution. Identity manager layer consists of these manager classes. We have already added the respective services with this method add identity API endpoints along with adding the entity framework stores. So an instance of this user manager comes from the dependency injection that is done with these two method invocations here. Like we have seen with the DB context class, the dependency injection is done here, and from there, all the classes having a constructor parameter of this type will be assigned or shared with an instance from the dependency injection that we have configured here. Similarly, the dependency injection done for the manager classes will share an instance for this user manager parameter here. Now let's go ahead with user creation process. First of all, we have to create an instance of the model class app user. First of all, we have email and we'll assign the corresponding value from the body that we have passed to this post web API method. Now similarly, we have to assign the full name. Now in order to create an user, all we have to do is from this user manager, we can invoke this method create async. Inside that we can pass the user object that we have created. Now as a second argument, we have to pass the password. That's why we have skipped passing the password into this app user object. Now let's pass the same from this registration model password property. Now since we have an async method here, we can prefix this method invocation with the keyword avoid. At the same time, you could see that this async keyword is automatically added here. Now we have to store the return object from invoking this method into this variable result. Now based on how this operation is carried out, we can return the response from this web API method. For that, we can have this if clause. If this operation is successful, inside the result object will be having a boolean property succeeded. It will be set as true. In that case, we can return the response like this. Results.ok method can be called. Inside that, we can pass the result object. So this will return the response with a status code 2.1 indicating the user is successfully created at the web API. Else, we'll return the response like this. Instead of OK method, we'll invoke this method bad request. Now this is all we need for creating a new user inside ASP.NET Core Identity. Now depending upon your future requirements, you can extend this web API method. For example, if you want to verify the given email address from the user, you have to make the required changes inside this web API method. Okay? Now let me build this and let's create a new user. Now inside this Swagger UI, you could see the new post web API method that we have created, API/signup. Click on try it out. So first of all, we have the email address. For now, let's keep this password as it is, string. Then we have full name. Click on execute. You could see that we have got a response with the status code 400, meaning that a bad request is sent from our client side here. So here we have the response body having succeeded property is reset as false. To see the actual problem, you could inspect this errors array. So basically these are the errors or validation errors for the password that we have passed. So by default, the password must have at least one alphanumeric character, meaning that there should be at least one special character inside the password, then at least one digit, one uppercase. Now if you want to keep these validations as it is, you can do that. But if you want to customize these validations, you can do that also. So inside this Program.cs file, with this builder object, we could do this builder.services.configure method can be called. And here we want to configure the identity options. This collection of services can also be used to configure like we configure with the app object here. Along with adding services, it will also be used for configuring the added services. So here we go. We have this lambda expression with this options parameter. Options.password. Inside that, you could see the various validations applied to this password property. So first of all, I want to disable this validation for required digit. Let's duplicate this. Let's disable the validation related to the uppercase and lowercase requirements. Now, along with all of these, I want to enable a new validation. It goes like this: options.user. Inside that, I want to set this require unique email as true. By default, it is false, so no user can have same email address. Okay, so with that being done, let's build this project again. Let's try to create a new user again. Now let's specify the password. Now, by the way, these are the default validations applied to the password property. Required digit, which we have already disabled. Then we have the min length validation. At least there should be 6 characters. Both of these validations, lowercase and uppercase, are already disabled. And we have to keep this at least one special character requirement. And finally, you could see this unique character validation, which at the moment is set as 1. So technically it is disabled. Now suppose if it is assigned with a value more than 1, say 2, then passing a password like this, repetition of same character is not allowed. There should be at least 2 distinct characters. So that's what this validation implies. When it is set as 1, technically it is disabled. So at present, we have these 2 validations, minimum 6 characters, and there should be at least 1 special character. So here we go, string, then I will add this special character. In total, we have 6 characters. That's enough. Now let's provide a full name. Click on execute. Now you can see another error here saying that username is invalid, can only contain letters or digits. Now, as per the default identity model implementations, the username can't be blank. For this particular identity solution, we are not asking for the username. Nowadays, most of the application is not asking for username. Instead, they use email address. If you have such a requirement where username is required, you can pass that and do the required changes inside the Web API method. Okay. Now, in order to disable this error, we often pass this same email address into the username property. Now, before making the changes inside the Web API, first of all, let me copy this object to the clipboard. We'll need that for the next try. So here we go. Along with passing the email, we'll pass username with the given email address here. So that will solve the problem. Save this, build the project, back to the Swagger UI. Making changes inside the Web API will reload the page, and that's why we copy the last user object. Click on try it out, and let's paste the same here. Click on execute. Boom. So here we have successfully created the user inside the ASP.NET Core identity. Let's verify the same inside this user table. See, here we have the new user with given credentials. You won't see the password that we have passed. Before saving it, it will be hashed into a format like this. That concludes this first section. We have covered a comprehensive introduction to ASP.NET Core, and we have done an in-depth explanation on creating a new user or user registration with ASP.NET Core identity. In this section, first of all, we'll start with discussing all the things that you want to know as a prerequisite to user authentication. And then we'll implement the user authentication in ASP.NET Core identity using JSON Web Token. From now onwards, the discussion on the framework ASP.NET Core identity could be split into 3 parts. So first of all, we have client. It could be any API Explorer like we used previously, Swagger UI, or it could be Postman, or it can also be client-side applications developed in Angular or React. So whatever that is capable of making an API request into the Web API project. And then we have the web API itself developed in ASP.NET Core. And finally, we have the database. In this project, we are using SQL Server DB. Now for better clarity, I will split the web API into two parts. So first of all, resources, you could think of them as various web methods inside the web API. And then we have the framework ASP.NET Core Identity. Now in previous section, we have discussed user registration, in which we have created a new user or new identity into the identity solution that we have. So from the client side, we have made a post request into this URL. Along with the user details, we also pass user credentials like email and password. And the respective web API method handles the request by saving the pass user details along with the credentials into the SQL Server DB with the help of ASP.NET Core Identity Manager User Manager. Now as a next step, we are going for user authentication. So let's start with the definition itself. Authentication is the process of determining a user's identity. So during the authentication process, the web API expects the credentials which is first passed to the web API during the user registration process. Now it is the responsibility of the web API to check whether there is an identity with the given credentials. So that's what we are going to implement as part of user authentication in this video. So the process authentication involves authenticating a user and responding when an unauthenticated user tried to access a restricted resource. So as a first step towards implementing it, first of all, we have to add the respective service into this iService collection here. It can be done simply with invoking this method add authentication from the service collection. So here we go, builder.services.add authentication will add the respective services for authentication. Now into this method add authentication, we want to pass the argument saying how we want to authenticate the user, whether we want to use JSON Web Token or any other authentication standards. Before that, I want to discuss the involvement of the framework middlewares in this process of identity solution. Now, when it comes to an ASP.NET Core web application, whether it is an MVC or web API, both the incoming request and the outgoing response must go through some established middlewares inside the project. In this given illustration, you could think of these vertical blocks as different middlewares. Now, if you are not familiar with ASP.NET Core middlewares, you could go through this in-depth article. I have given the link in video description. So basically, there will be a chain of middlewares in between the actual request and the destination of the request, and there will be similar middlewares while returning the response. You could think of these middlewares as a common necessary interruptions for the proper working of the app, and each one of them works one after other in sequential order. So the order does matter. Now inside this table, you could see the available built-in middlewares in ASP.NET Core Framework. Some of the middlewares will be added by default into the project, and rest of them could be added as per your requirement, like these authentication and authorization in this project. Both of them should be added into this project with the respective method. Now just now we have added the required services for authentication purpose, and through this method we will say how we want to configure the authentication. But it won't add the necessary middleware into this application. For that, we have to invoke the use method useAuthentication. That will add the necessary middlewares for the authentication purpose. And that also must be done in the proper order. Among the middlewares that precede the authentication middleware, the CORS middleware is the closest one in sequential order. I will explain what is meant by CORS and how the middleware works in a bit. And then we have to add the middlewares for authentication and then authorization. So this order must be followed. So that's what I have shown as an example inside this illustration. This order must be followed. And most importantly, all of these middlewares must be added before adding the web API methods inside this project. We have to do the authentication or authorization before accessing the protected resource. Then only we can protect the resources from unauthenticated user. So first of all, let me start with adding the middleware for CORS, which is not necessary for this web API project. But to make you understand the concept very well, I will add the respective middleware. Some of you might have experience with configuring this CORS middleware. CORS stands for Cross Origin Resource Sharing. So by default, a web API project will deny a request coming from a source having a different domain name or different port number. In order to allow such a request from a different port number or URL, we have to add that into this course middleware. For that, all we have to do is from this app object, we can invoke this method app.useCourse. Through the arguments of this method, we can grant access for external applications to consume this web API. So we have added the respective middleware into the web API project here. Now for this demo project, we don't have to configure this course middleware. So I will wrap it inside a region like this. Let it be config course. Already this program.cs file is cluttered. We'll organize everything into respective files and folders in next video. So let me for this region here. So here we have added the course middleware, and then here we have the method invoked by default inside this project, use authorization. It will add the necessary middlewares for the authorization. We'll talk about the middleware later in this video. We have added these two middlewares, course and authorization. In between, we have to add the middleware for authentication. For that, all we have to do is just invoke this method, use authentication. So with this method, add authentication, we will add the necessary services to the app and configure how we want to authenticate the user. And such a logic will be executed with the adding of this middleware here. In between these middlewares, course and authorization. So hope you understood. Now with this method add authentication, we want to specify how we want to authenticate the user. Now before getting into the implementation, I think it would be more helpful if we organize the terms that we already heard of related to authentication or authorization. I mean the standards or protocols that we most often use for authentication and authorization. At the same time, we are not getting into any details of these standards here. In this tutorial, we are only discussing JSON Web Token. I just want to make you aware of the alternatives that is related to this topic. In that way, you will not get frightened when you hear these fancy terms while you research the topic further. So first of all, we have OAuth 2. So that is a standard, which is then extended into this OpenID Connect, in short OIDC. And then we have JSON Web Token. So these are the most commonly used or most well-known standards for authentication and authorization. Apart from them, you could see Security Assertion Markup Language, SAML, System for Cross-Domain Identity Management, and then we have finally Web Service Federation. If you want to know more about these standards, I have given the link to this article in video description. You can go through them and could study more about these standards. In this particular tutorial, we are using this standard JSON Web Token, in short pronounced as JWT. Now regarding this topic of authentication and authorization, you could see various categorization like based on different aspects of the process like password authentication, then biometric authentication, etc. and etc. All of the categorizations are done based on different aspects in the process. Okay. Now, before discussing JWT or JWT authentication in detail, we should be familiar with one more type of categorizing authentication methods. They are session-based or cookie-based authentication versus token-based authentication. These two types of authentication are more common when it comes to implementing authentication, particularly in web applications. While going through the documentation itself, you could see the terms like token-based authentication or cookie. So learning how these two types of authentication works and how they differ will give you a clarity on this topic of authentication. So first of all, we have session-based or cookie-based authentication. Now in this whole illustration, this part here represents the client browser. And here we have the server side consisting of the web API or the MVC application along with the database. And in between, you could see the request and response in between these two parties. So first of all, here we have the post request trying to log in into the web application here. And inside the server, the given credentials are verified. And if there is a user with given credentials, a new session record will be saved into the database. proving that this particular user is successfully authenticated into the system. As a response to this request, the session ID which we have saved into the DB will be returned. And then inside the browser or client side, the received session ID will be saved to the browser cookie. Inside your browser, if you open the developer tools, you could see application. Inside that, you could see the cookies related to each website. So for this application, this much cookies are saved. Similarly, the session ID will be saved to the browser cookie, and from there onwards, in order to access any protected resource from the web application, we have to pass the session ID as the cookie inside the request. And then inside the server side, before the request reaching its destination, the in-between authentication middleware will verify whether this session ID is present among active sessions. So while considering active sessions, the expired sessions will be ignored. And if this verification is successful, the request will reach up to its destination, and then the proper response will be sent back to the client side. So that's how session-based or cookie-based authentication works. Now when it comes to token-based authentication, it is stateless, meaning that there is no involvement of database like we've seen in cookie-based authentication. There is no record saved in database proving that a particular user is successfully authenticated to the system. Now JSON Web Token Authentication or JWT authentication comes under token-based authentication. So here it goes. First of all, the user makes a post request trying to log in into the web application. And then of course inside the server side, the given credentials must be verified with already stored users inside the solution. And if this verification is successful, then a token will be generated. In case of JWT authentication, the token is called as JSON Web Token, in short JWT. The same token will be returned as a response to the request, and then inside the client side or browser, the JWT will be saved somewhere persistently. That would be outside the browser cookie. Most often that would be the local storage inside the browser. You could see that inside this developer tools itself, local storage and all the local storage key value pairs for this website could be seen here. So a key value pair like this will be used for saving the received token as part of a successful authentication here. And from there onwards, in order to access any protected resource from the server side, we have to pass the JWT inside the authorization header of the request, in which along with passing the JWT, we have to pass the prefix bearer. Don't worry about this, we'll be showing you how to send this JWT inside the request authorization header. This part of validating token signature is really important because inside this token-based authentication, there is no involvement of database to check whether this user has already authenticated to the system or not. We could discuss that in a bit. So if the token signature is validated successfully, then the request will get the access to the protected resource, and then the respective response will be sent back to the client side or browser. So that's how cookie-based authentication and token-based authentication differs. Inside the cookie-based authentication, a record is saved to the database proving that this particular user is successfully authenticated to the system. When it comes to token-based authentication, there is no involvement of database for storing the record proving that a particular user is successfully authenticated to the system. So that's one of the important difference between these two types of authentication. Along with them, you could see the difference in how the session or token is saved inside the browser, and from there on how it is passed to the server for accessing protected resource. Now let's dive deep into JWT authentication and let's see how it is able to do everything without saving any state of the authenticated user in a database. For that, here we have the official documentation of JSON Web Tokens. So first of all, we'll discuss how the JSON Web Token is generated. And then we can discuss how it is getting validated in the subsequent request. So basically, JSON Web Token has three parts: header, payload, and signature. And each of these are separated with a dot or period symbol in between them. So typically, the header part consists of two properties or two informations. First of all, we have sign-in algorithm and then the type of the token. Since we are dealing with JSON Web Token, we will set it as JWT. And with this property ALG, which stands for algorithm, into that we have to pass the algorithm that we used for encrypting this signature here. I will explain that in a bit. So most often these two algorithms are used, SHA-256 or RSA algorithm. In a bit we'll be explaining how this algorithm plays a role in generating the JSON Web Token. So the first part of the token will be base64 URL encoded version of this JSON object here. The intention or meaning of the URL encoding will be discussed later. And then comes the payload. So basically payload consists of claims. Claims are statements about the entity that would be the authenticated user and then some additional data about the token that we are generating. For example, inside this payload you could see that the admin property is set as true, meaning that this logged user is an admin, and then here we have the corresponding user ID from the database, and here we have the full name of the logged in user. Along with these user related claims, you could see claims like this IAT. Those are the statements or additional information about the token that we are generating. You could see such predefined claims inside this documentation here. If you want to know what this means, you can search for IAT. See, it represents the time of issuing the token. So such informations or statements will be there inside the payload. Now before adding the payload into this JSON Web Token, the same will be converted into base64 URL encoded version. In between both of these header and payload, there will be a period separating them. And finally here we have the important part of this JSON Web Token, signature. Inside this signature, we are not hiding any extra information than what we have inside this header or payload. So this signature is generated using the algorithm that we have passed inside the header here. See, the same algorithm is used here for generating this signature, SHA-256. So this encryption algorithm will take this part here from the beginning of the token up to this second dot here will be taken as the input for the encryption, and then the same will be encrypted with a secret key that we have passed to it. Now as you know, the JSON Web Token is generated as a result of successful authentication of a user. So this secret key must be private and should not be exposed to anyone outside the server. As long as the secret key is not available, no outsider can modify or break into this generated JSON Web Token. More about that could be discussed once we generate the JSON Web Token. So back to the project. At present we only added the services for authentication here, and the corresponding middleware is added here with the app object. So before generating the JSON Web Token, we have to configure the authentication with the authentication standard we are using. So that would be JSON Web Token. For that, we have to install the NuGet package to work with JSON Web Token. So right click on packages, then manage NuGet packages. Inside this browse tab, search for this NuGet package, which I have given in the video description. You can copy paste from the Authentication JWT bearer. Let's install the package. So the installation is successful. Now back to the Program.cs file. Now to this add authentication method, we'll be passing a lambda expression like this. Now inside this lambda expression, we are going to pass authentication options. So these are the available authentication options that we can pass to the lambda expression. So here we go, x dot default authentication scheme, and then we have default challenge scheme, and then we have the default scheme itself. All of these three schemes will be assigned with JWT. So here we go, JWT bearer defaults dot authentication scheme. Now it's necessary to know what is a scheme. It's a combination of authentication handlers and their configuration. So you could think of these authentication handlers as methods defining how to handle a requirement in the process of authentication, and along with its configuration options together is called as schemes. So back to the authentication options here. Along with the schemes that we are passing here, you could see other schemes inside this table that the ASP.NET Core identity is asking for. So this default authenticate scheme expects a scheme containing the basic core handlers related to the authentication process. And then this default challenge scheme expect a scheme containing handlers defining how to handle an unauthenticated request. And apart from these two schemes, authenticate scheme and challenge scheme, you could see other schemes inside these authenticate options. So for such schemes, we have not specifically set the scheme. So by setting this default scheme, all of such other schemes will be assigned with the scheme that we are passing here. So all of these schemes and rest of them is assigned with the JWT authentication scheme. So everything will be handled by JWT authentication scheme itself. In certain applications, there could be multiple authentication standards used. In those situations, these schemes could have different values or different schemes assigned to them. Now, we need to register the JWT scheme with necessary configurations. For that, we have to invoke this method, add JWT bearer method. Now, inside this method, we have to configure or tune the JWT authentication as per our requirements. For that, here we have the second lambda expression. First of all, we will say whether we want to save the token or not. Since we are going for JSON Web Token authentication, we will set it as false. Now we are going to specify how we want to validate the token for subsequent requests after a successful authentication. As I said already, how it works will be discussed once we generate the JSON Web Token. For now, let's configure how we want to validate the token. For that, we can assign this property token validation parameters. Now, in order to validate the token signature, we have to set this property as true. And to do the same, we need the secret key of the encryption. This secret key, we need this for validating the JSON Web Token. So here we go, issuer sign-in key is equal to, this option only accept an instance of this class symmetric security key. Inside that, we want to pass the encoded version of the security key. Now we'll save the security key inside this AppSettings.json file. So here we go, app settings. Inside that, we'll have this secret key JWT secret. Now this secret key must be having at least 32 characters. For this demo project, we have set the requirement of the secret key itself as the secret for the JWT authentication. So make sure to provide the secret key having 32 characters. Now let's pass the value of this key to this method getBytes. So here we go, builder.configuration. Now let's provide the path of the key. So inside app settings, we have JWT secret. Now you could see a green squiggly line here saying there is a possibility of null inside this key. We already provided a value for this key. So at the end of passing this key, you can add this exclamation mark like this. So in this way, we can turn off the possible null error warnings when you can always ensure a value in the context. So first of all, we have reset this boolean property saying that we don't want to save the JSON Web Token after its creation. And with this property, we have specified how we want to validate the JSON Web Token in the subsequent request after a successful authentication. We want to validate the signature of the token, and here we have provided the necessary key or secret key for the validation purpose. We will be discussing how the signature is getting validated once we generate the token. Now it's time to create a Web API method for login or sign-in operation. So we'll be making a post Web API method with this URL. Inside the body of the request, we'll be passing the email address and the password of the user. And inside the Web API method that we are about to create, we will check whether there is a user with the given credentials inside the DB with the help of ASP.NET Core Identity User Manager. And if it is successful, we'll create the JSON Web Token, and finally from the Web API, we'll be returning the JSON Web Token to the client side. So at present, inside this Program.cs file, here we have the Web API method that we have created for user registration. So let me copy this and let's follow this Web API method, and just beneath that we can add this Web API method with this URL sign in API/sign in. And here we have the lambda expression to handle the request. Now let me copy paste the parameter from this user registration Web API method. we need the user manager. In order to receive these two credentials, email address and password, we are going to create a model class like we have done for user registration. For that, let me copy paste this. This is login model. Inside that, we only need email and password. At present, this program.cs file is messy. We will be organizing everything into respective files and folders in next section before authorization. Now, instead of user registration model, we have login model, and let's rename this parameter also. Now, with the help of this user manager, we have to find if there is a user with the given credentials or not. So here we go. User is equal to user manager dot find by email. Async method can be called. Into that, we can pass the email from the model that we have here. Now, since we have an async method here, we can prefix the method with the avoid keyword, and that requires an async method just before this lambda expression here. Now, we have only checked if there is a user with the given email address or not, because we can't check for the received password inside the DB. During the user registration itself, the password is hashed. So for that, we'll be using a separate method. So here we have the if clause. First of all, we'll ensure there is a user with the given email address. And here we'll do the password comparison. For that, we can invoke this method check password async. As a first argument, we have to pass this user object itself, and then we have to pass the password that we have received through the request body. Now, this method will check whether the given password is the correct password for the user. Now, if it is successful, we'll handle the request inside this if clause here. Else, we'll return a bad response. So here we go, return results dot bad request. Inside that, we can pass this object. Message is equal to username or password is incorrect. Now, inside this if clause, let's go ahead with generating the JSON web token. For that, first of all, I will save the encoded version of the secret key that we have here into a variable. So here we go, sign in key. Now actually, we are already done that inside this JWT configuration options here. So let me copy this and pasting the same here. Now we want to describe the token that we are about to create. So that would be deciding what are the claims or informations that we want to add into the payload. Once the header and the payload is available, the signature could be generated or encrypted with the algorithm that we have specified here using the key that we have saved inside the AppSetting.json file. So all we have to do is just describe what are the informations or claims that we want to pass into the payload of the token. So here we go, token descriptor. Into it, we'll be assigning an instance of this security token descriptor. Now, through this property subject, we can pass the custom claims like user ID, role of the user, etc. and etc. So into this property, we'll be assigning an object of this class claims identity. And the constructor of the class expect an array of claims. For now, we only have a single claim. Inside that, we'll be providing the user ID. So here we go, new claim. The name of the claim will be user ID. Now the user object corresponding to the credentials that we have here will be the inside this user object here. From that, we can access the user ID. And let's convert it into string format. So at present, we only have this custom claim. As per the future requirements, we can add necessary claims into this token generation process. Then after the custom claims, we can set the expiry for the token. Instead of add days, let's invoke add minutes method. So the newly generated token will expire after 10 minutes. And finally, with this property sign-in credentials, we have to pass the sign-in key that we have saved inside this JSON file, along with the algorithm that we want to use for the encryption of the signal part. So here we go, new sign-in credentials. As a first parameter, we have to pass the sign-in key here. Then as a second argument, we can pass the algorithm, security algorithm. This particular algorithm could be passed, SHA-256 signature. So here we have passed whatever we needed for the payload, and here we have passed the sign-in key along with the algorithm that we want to use for the encryption of the signature. Finally, in order to create the token, first of all, we want to create an instance of token handler. For that, we can create an instance of this JWT security token handler. Now let's create the token, security token. From this token handler, we can invoke this method create token. Into that, we only want to pass the token descriptor that we have created here. Now finally, in order to convert this token into a serialized format, we'll create a variable token. So this is the actual token that we want to pass as a response to the post request. All we have to do is from the token handler, we can invoke this method write token. Inside that, we can pass the security token here. Now all we have to do is just return the response within this OK method. We have to return it within an object token. Now let's build the project. Now back to the Swagger UI. So here we have the post request that we have just created, API/sign-in. Now click on try it out. Now let's pass the user credentials of the user that we have created in previous video. So email is equal to email@gmail.com. And then we have password. The correct password was string, then a pound symbol or hash symbol. Now in order to test the working of this web API method, let's try with wrong credentials. So I will set the password as string. Click on execute. So here we have the bad request with the message username or password is incorrect. So that is from this else block here. Now before passing the actual password, let me increase the expiry time using the method add days, so that we can avoid the situation where the generated token will get expired before explaining the related topics. So let me build this project again. So that will reload this API Explorer here. Let's try to make the same request, but this time we are providing the correct credentials, email, then password. Click on execute. Boom. See, here we have the JSON web token. Now let me copy paste the same into a notepad for closer inspection. So first of all, we have the header, then payload, then finally signature. All of them are separated with a dot in between them. So here we have successfully implemented the web API method for login or sign-in operation. First of all, we have checked whether we have a user inside the stored list of users with the given credentials here. And if there is such a user, the web API will create the JSON web token and it will be returned as a response back to the caller. So inside the previous illustration about token-based authentication, we have completed this part here. Now, if you are making this request from a client-side application, you have to store the received JSON web token somewhere persistently. Most often, the browser local storage is used because we need to pass the same for accessing any protected resource from there onwards. And once such request asking for protected resource reach in the web API, the passed JSON web token will be validated inside the server side. So that's what we are going to discuss in rest of this video. We'll be making a request for accessing protected resource along with passing the JSON web token once we discuss the authorization. So that will be discussed in the section after the next. In upcoming section, we'll discuss how to organize everything what we have inside the Program.cs file. Now let's see how the token or token signature is getting validated inside the server side. For that, I will make use of this debugger inside this official documentation. Now let's switch into the dark mode. So this is how it works. If we provide the received token here, the containing header and payload will be decoded here. And with this last portion, we can verify the signature. So let me copy this and pasting the same here. Let's remove the new lines that we have added. Now you could see the decoded header and payload of this token here. Here we have the algorithm that we have used, SHA-256, and here is the type of the token, which is JWT. Inside the payload, you could see the ID, user ID that we have passed inside the web API method. You could verify that from this user's table here. See, the same ID is the pass into the payload. Then we have the expiry time as per the configuration we have given during the token generation process. Now other than those two, we have IAT, which stands for issued at time. NBF stands for not valid before, which exactly have the same data that we have inside the IAT, meaning that this token is not valid before the issued time here. Okay. Now you should be careful while describing the token like we have done here. Whatever we pass inside the claims or payload can easily be decoded because the URL encoded format of the payload is directly added to the token. Now the process URL encoding is the process in which the characters that we have is converted into a format that can be transmitted over the internet. To be specific, the converted output from the process should be safe to pass within the query strings of the URL. So that involves replacing special characters in the data with respective encoded versions. So make sure to avoid passing crucial data through the payload. It could be easily decoded by pasting the JSON web token inside this part. Can also be decoded easily with the respective decoding methods. For example, in case of JavaScript, if you pass this payload here into this method ATOB, we will get the decoded version. Let me try that here. ATOB. Inside that, let's pass the string. So here we have the encoded version of the payload. Now let's execute the method. You see here we have the string version of the payload that we have passed inside this JSON web token. You could see the same here also. So that's how easy it is to decode the URL encoded version of the payload or header. Now the actual protection is inside this third part here, signature. Now like we have discussed previously, this signature is formed by encrypting this part here from the starting of the token up to this second dot here. And for the encryption process, we have passed a secret key. Now during the process of validating the token signature, the signature part will be recreated by encrypting this part with the signature that we have saved inside this server side here. Now let me illustrate the same with this debugger's third part here, verify signature. Inside this part, this much portion will be taken as the input for the encryption using this algorithm SHA-256 using the secret key that we provide here. So whatever secret key you provide here, this much portion will be encrypted with the key that we have provided here. And the result will be updated in the signature part of the token. And here you could see the feedback saying signature verified. So meaning that this signature is the exact encryption of this part with the given secret key here. That's exactly how we create the signature. Now whenever we change any of these values inside this header or payload, you will get this feedback invalid signature. Meaning that encrypting this much part with this given secret key does not match this signature here. So that's how the debugger validation feedback works. Let me undo the change that I have done. Now let's go ahead with the actual procedures involving invalidating a token signature. Inside this notepad, we have the original JSON web token. So during the verification of the signature inside the web API, this much part will be encrypted with the key that we have saved inside this app settings here. And then the resulting signature will be matched with the received signature. Let's see them in action inside this debugger. For that, first of all, I will clear this signature. Now let's copy paste the secret key inside this debugger here. Now this signature will be matched with the received signature. See, both of them match each other. And thereby the verification of the token signature is successful. The user will get access to the protected resource. And if needed, they can make use of the information that is received through the token payload. Now let's see how much safe is a JSON web token. Suppose a hacker got this token from someone successfully authenticated to the system. They can easily decode the payload, and if they want to change any of the information like user ID, role or whatever it may be, they can do it without a problem inside the payload. But during the token verification process, it will be caught because inside this signature, the original payload is encrypted. So anyone outside the server can't do anything without the secret key that we have saved inside the web API. So this token is protected by itself because there is a signature of the actual data passed through the token. So hope you understood how the token signature is getting verified while accessing a protected resource. Now this will be done in action while doing the authorization. As I said already, we'll do that after the next section. In this section, we'll be discussing how to organize everything inside Program.cs file of an ASP.NET Core Web API project into respective files and folders. That's really important because already this Program.cs file is messy. So here is the initial Program.cs file and here is the final output. Now without further ado, let's get started with the topic. Before getting into that, we should be familiar with the C# extension methods. Keep in mind that it's not static methods, the feature is called extension methods. Now consider this part as our Web API project. Into that we have added a necessary framework called ABC. Now suppose inside that we have an interface or class called original. The implementation of this type original is already done within the framework with its own methods and properties. Now using the C# feature extension method, we are going to extend this type original by adding our own methods from this Web API project here. Say we have an object org1 which is of the type original, that is from this framework here ABC. Now using the C# extension methods, we have added these two methods into the type original. Now let's see how it is done. So first of all, we have a static class. Inside that we have two extension methods for this type original. All we have to do is the method must be static and the first parameter to the method should be of the type original. And make sure that the parameter is prefixed with this keyword this. Then such a method will act as a method defined inside the type original. And that's how we are able to invoke these two methods from the same type. Even though both of these methods are not there inside the original implementation inside the framework here, we could add methods like this from our Web API project like this. Finally, there is a warning. Make sure that there is no such method already present inside this original implementation here. We can't override an existing method with this feature extension methods. Now we are going to make use of this feature for organizing the Program.cs file. Now first of all, inside this Program.cs file, let's add extension method to the type of this services collection. You could see that it is having the type of this interface iServiceCollection. So to be specific, we are going to add an extension method to this interface iServiceCollection. For that, first of all, I'm going to add a new folder called extensions. Now inside the new folder extensions, we are going to add a C# class file corresponding to this outer static class here. So here we go. Inside the new class we are about to create, we'll be adding extension method related to ASP.NET Core Identity. So I will name this class as Identity Extensions. Now some of you might have noticed it. The outer static class name is nowhere mentioned while invoking these containing extra methods. See? And for the same reason, we should be providing some meaningful name for the outer class. Like we have given here. Inside this class, we'll be only having extension method related to ASP.NET Core Identity, and thereby you could easily navigate the extension method inside the project. So first of all, we have to make the class as static class identity extensions. Now I'm going to add an extension method for what we have done here, in which we have added services for identity handlers and corresponding entity framework stores. So here is the new extension method, public static void. I will name the method as add identity handlers and stores. Now we have already made this method as static like we have seen here. Now we also need a parameter of the type iServiceCollection, which is the type of this services here, iServiceCollection. So here we go, iServiceCollection, and I will name this parameter as services, As a prefix, we have to use this keyword this. So here we go. Now this method add identity handlers and stores became an extension method of this type iServiceCollection. So you can invoke this method from this type iServiceCollection from this program.cs file like this. Builder.services.add identity handlers and stores. So this is the method that we have just added, the extension method. Now let me cut this and pasting the same inside this new extension method. The iServiceCollection is already here as a parameter, so we can invoke these methods from these services here. So here we go. Services dot add API endpoints and then add entity framework stores. So this is how we are going to add extension method throughout this program.cs file. Now the proper naming of extension methods like we have done here will help you to remove comments like this. Now here we have configured the properties of user, password and email address for user registration. So to do the same, I'm going to create another extension method. For that, I will just copy paste the signature of this method. I will name this method as configure identity options. Let's move this statement into the new method. We can invoke this method from this services parameter itself. So here we go. Sorry, here we need an extra curly bracket. That's it. Now we can invoke this new extension method from this program.cs file. Builder.services configure identity options. So hope you are realizing that how C# extension method is helpful to organize codes like this. Now we could make this even more better. Instead of returning void from this extension method, we can return this interface type iServiceCollection. So at the end of invoking these methods, we have to return these services like this. Return services. Let's do the same for the second extension method also. We have set the return type as iServiceCollection, and after invoking these methods, we have returned the services here. Now by doing this, instead of invoking these two methods separately from the services, we can change the invocations like this. This method is already returning an iServiceCollection. From that, we can invoke this second extension method. So all we have to do is just change the invocations, method invocations like this. Okay. Now let's define an extension method for injecting the DB context here. It's not related to identity, so I'm going to create a new C# class file, EntityFrameworkCore.Extensions. Let's make this class as static. Now here we have the extension method public static. Now instead of defining from start, let me copy this signature from here. I will name this method as inject DB context. Now let's move this statement for the DB injection into the new extension method here. We can invoke this method add DB context from the service parameter. Let's add the required using statements. Now to this method useSqlServer, we have to pass the DB connection string that we have saved inside this JSON file here. For that, we have to pass this configuration from the program.cs file. So first of all, let me add a parameter of the type iConfiguration. Let it be config, and we can invoke this method getConnectionString from this config object. At the end of this method, we have to return the services. So here we go. Return services. Now let's invoke this method inject DB context from this program.cs file. That we can do through chain invocations like this. Into this method, we have to pass the builder.configuration object. Now instead of naming this method as inject DB context, we could have named it like add DB context. But such a method is already present inside the type iServiceCollection. That's what we are invoking here. So that's the reason why we have named it like injectDB_context rather than addDB_context. As I already told you, we can't override an existing method with an extension method like this. Now, in previous video, we have added authentication services from ASP.NET Core with this method invocation. Inside that, we have given necessary configuration for JSON Web Token authentication. For that, I'm going to create a new extension method inside this identity extensions. First of all, I will copy paste this last extension method and let's clear everything inside that. I will name this method as addIdentityAuth. Often I use this abbreviation auth to mention operations combining both authentication and authorization. At present, we have only added the authentication services. In next video in this series, we'll be adding authorization also. So that also will be done inside this method addIdentityAuth. So let me cut this and paste the same here. Let's invoke the method from services parameter. Now here also we need the configuration object. So we have to add the second parameter like we have done here. Let me copy this and pasting the same here. Now let's replace this builder.configuration with config. Now back to the program.cs file. Let's invoke the new extension method addIdentityAuth. As an argument, we have to pass the builder.configuration object. Now if possible, change the order of invoking this method for better grouping. Everything related to identity will be called in sequential order. So first of all, I will invoke this injectDB_context. Then we have addIdentityHandlers, then configuring the identity options, and then we have added the services for authentication and authorization. As you can see, the program.cs file is already getting cleaned. Now, as the next step, we want to add extension method to the type of this app object. Before doing that, I want to add one more extension method for statements related to Swagger UI. For that, I'm going to create a new C# class file, Swagger extensions. So here we have the static class. Now let me copy paste an already existing extension method. I will name this method as addSwaggerExplorer. Let's clear everything inside the method and let's cut and paste what we have here. Let's invoke this method from this services parameter. Now let's invoke this method inside the program.cs file. addSwaggerExplorer. For now, I would like to keep this addControllers method as it is. Now we need to add few more extension method to the type of this app object. First of all, here we have the if clause to configure the Swagger API Explorer. For that, I'm going to add a new extension method to the Swagger extensions here. Let me duplicate this last extension method. Previously, we have been adding extension method to the type of this iServiceCollection. But in case of this app object, we have to add extension method to the type of this class web application. So we have to change this parameter accordingly. Instead of this interface, we want to extend this class web application. I will name this parameter as app. We want to return the same type from this method. So let's change the return type to web application. Now let's rename this method as configure Swagger Explorer. Let's empty the method. And finally from this method, we'll be returning this app object. Now let's move this if clause into the new method here. Now we can invoke the method app.configure Swagger Explorer. Now inside this region, we have invoked this method useCourse for the sake of explaining the previous topic. Now if I were creating an extension method, I will be doing that inside a C# file like this, app config extensions. So here we have the static class. Let me copy paste the last extension method that we have created here. I will name the method as config course. Let's clear the method. Now let's move this method invocation into the new method here. Now we don't need this region anymore. Now we can directly invoke the method here, config course. Now you know what, for configuring the course, we may need data from this AppSetting.json file. So in those situations, we have to pass the configuration object like we have done here. So let me copy paste the same here. Now we have to add the necessary parameter inside this extension method. iConfiguration as config. Okay. Now let's add our final extension method for adding these authentication and authorization middleware that we can do inside this identity extension clause. For that, first of all, let me copy paste this extension method into the clause here. I will name the method as add identity auth middlewares. Let's clear everything inside the method and let's move these two method invocations into it. Let's cut this and paste the same here. Now let's invoke this new method like this. Actually, we could change this method invocation to the invocations here, so I will do this. So far, with the help of C# extension method, we have organized every method invocations related to adding services and configuring services like this. Now rest of the portions inside this Program.cs file deals with Web API methods. First of all, you could see this method invoked here, map controllers. It will configure or add routes from traditional controls like this weather forecast control. This is the default control that's already been there inside the new project template. So the routes from conventional Web API methods like this will be added with this method invocation here, map controllers. But so far inside this project, we have used minimal Web API methods, and that's how we are able to define the methods inside this Program.cs file itself. But doing all of them here kind of mess up the whole purpose of Program.cs file. Now let's organize these Web API methods properly. Now before this user registration and login Web API methods, you could see this method invoked here, map identity API. We have invoked this method for adding routes from identity framework into this project. And rest of these Web API methods are custom Web API methods that we have added throughout this series. Now let's look how to organize these Web API methods or the Web API methods that we are about to add going forward in this series. We are going to use the same concept that we have used so far, that is C# extension methods. Let me walk you through it. Inside this controllers folder, I'm gonna add a C# file. I will name it as identity user endpoints. Like we have done for these extension classes here, we are going to make this class as static. Now inside this class, we'll be adding Web API methods related to the entity identity user. For that, first of all, let me copy paste an extension method that we have already created here. So far, we have been adding extension method to the class web application or the interface iService collection. But in order to work with minimal Web API methods, we have to extend this interface iEndpoint router builder. I will keep the parameter name as it is, app, and I will set the same type as the return type of this method. Now let's rename this method as map identity user endpoints. Let's clear everything inside the method. So as I said already, inside this class, we'll be adding Web API methods related to the entity identity user. So both of these web API methods will be added into this class here. So from this program.cs file, we can invoke this method map identity user endpoints. Now you might be asking this. Here we have added this extension method to the type of this interface iEndpoint route builder. But here in this program.cs file, we have invoked the method from the type of this app, which I present inside this program.cs file, which is having the type of this class web application. How it is possible? It is possible because this interface here is a derived type of the class web application. See, this interface is derived from this class web application. So the parent type can invoke the children methods. That's what exactly happened inside this program.cs file. We have already done the same while defining these two web API methods here. This method map post is actually a method of this interface iEndpoint route builder. And here we have invoked it from the parent type app, which is having the type web application. See? So let me move these two web API methods into the new method here. Along with these web API methods, we also need these two classes. So let me cut this and pasting the same outside this class here. Now let's add the required using statements. Now here you could see an unresolved error due to this builder object. It was readily available inside this program.cs file, but inside this endpoint class it's not available. We'll fix that in a bit. Now we can organize these web API methods even more better. For that, outside this extension method, I'm gonna create a private method like this, private. This class is already static, so the containing method should also be static. And here we have the method create user. Now we are going to move this lambda expression into the new method that we have created here. For that, first of all, I will cut everything inside this lambda expression and pasting the same here. And let's cut these parameters here. Now from this method, we are returning an HTTP response. So we have to provide the corresponding return type for this method. That will be task of the type iResult. Now all we have to do is just replace this method in place of this lambda expression here. Now since the method contains asynchronous operations, we have to prefix the method with this async keyword here. Now let's do the same for the second web API method for the sign-in operation. Let me copy this method signature from here. I will name this method as sign-in. Now we have to replace the method parameters with what we have inside this lambda expression. Now let's move everything what we have inside this lambda expression. Now instead of this lambda expression, we can pass this method sign in. That's it. So with this method invocation inside this program.cs file, map identity user endpoints, we have mapped every web point related to the entity identity user. At present, it contains the web API methods for user registration and sign-in operation. Now in order to avoid repeating this part of the URL in all of the web API methods, I will invoke this method map group before registering the web API endpoints like this. So all of the containing web API methods will get this prefix in the URL. So we no longer need to repeat this part of the URL /API. So this is how we are going to deal with web API methods. Now of course inside your project you will be dealing with different entities. Suppose you are creating this web API for an e-commerce website. In those situations, you will be dealing with orders. So, to define web API methods related to the order, you will be creating a separate class like we have created here. For example, let me add the class file order endpoints. You will change this class into a static. Inside that, you can define an extension method like we have done here. That will be map order endpoints. So all of the web API methods related to the order can be added to the extension method like we have done here. At the end, in order to add such web API methods into the project, we can invoke the extension method map order endpoints here. So that's how to deal with web API methods. Now finally, we have to resolve this error related to accessing configuration data from the builder object. This builder object is not available inside this class here, identity user endpoints. But we could pass the builder object from this Program.cs file like we have passed the builder.configuration in rest of the extension methods here. But that's not a best practice when it comes to web API methods, because we will be passing first to the map method here. From there, we will be passing the same to this method sign in. In order to avoid the inconvenience in passing the builder object, we can make use of dependency injection. Let me show you the proper way to do it. For that, first of all, I'm going to define a class representing the data inside this AppSetting.json file. Because inside these methods that we have created here, it is trying to access the configuration values. So first of all, I'm going to define a class inside this models folder, AppSettings. At present, with this class, I want to represent this key here, AppSettings. As you go further with the app development, you will be adding more key value pairs into this AppSettings. So all of those properties could be added to this class here. So at present, we only have this property JSON secret. So let me copy this and let's define a property with the same name, which is of the type string. So here we have created a property with the same name as that of this key here. Now back to Program.cs file. Now like we have injected an instance of this DB context, I'm going to inject an instance of this class AppSettings with the corresponding value that we have inside this AppSettings.json. So here we go. From this services collection, we can invoke this method configure. Now here we have to provide the type of this class AppSettings. Now into this method, we have to pass this section here, AppSettings. So here we go, builder.configuration.get section method can be called. Inside that, we can pass this section, AppSettings. So with this statement here, an instance of this class AppSettings will be created, and the containing properties will be assigned with the value with the corresponding key value pairs from this section here. Now any web API method can access the properties inside this AppSettings if there is a corresponding parameter inside the web API method. So for example, for this web API method, sign in, we have to access this JWT secret. So we can do this. To this method, we'll add this parameter iOptions of the type AppSettings class, and we'll name this parameter as AppSettings. Now in order to read this key JWT from the JSON file section AppSettings, we could do this AppSettings. Inside that, we have this object value which is corresponding to the class here AppSettings. From that, we can access this property JWT secret. See, that's simple. Like this, you can access any property that is added to this class AppSettings. So that's how to do dependency injection for properties or values or informations inside this AppSettings.json file. Now finally, let me move this into a new extension method that we can do inside this class AppConfig extensions. For that, let me copy paste this extension method for the DB injection. I will name it as add AppConfig. Let's clear the method. Let's cut this and paste the same inside this new extension method. Instead of builder services, we can make use of the services parameter. We already have this object inside this parameter config. That's it. Now let me invoke this extension method just after the injection of the DB context. Here we have to pass the configuration object builder.configuration. That's it. So that's it guys. In this program.cs file, we have organized everything into respective folders and files with the help of C# extension method. So before going forward, let's verify the proper working of the web API methods that we have done so far inside this project, that is user registration and user login. So let me run this project. First of all, let's create a new user. Let's make the request. So here we have successfully created the user. Now let's try to log in with the same credentials. For that, here we have the post request sign in. Try it out. Let's make the post request. Boom. So here we have the JSON web token as a result of successful authentication. So that's all about organizing the program.cs file. In first section, we have discussed user registration. Then in the following section, user authentication is implemented with JWT, and how to organize program.cs file is covered in last section. Now in this section, we'll discuss all about user authorization. Now let's start with comparing the process of authentication and authorization. Authentication verifies whether a user is an insider or not. Now, the process authorization grants access to protected resource only if the user has necessary permission. We have already discussed authentication in great depth and implemented the same. Now, let's deal with authorization. Now you could see the same comparison inside the official documentation. Authentication is the process of determining a user's identity, while authorization is the process of determining whether a user has access to a resource. Like we have seen, during the process of authentication, the user will be making a post request with their own login credentials, and then the identity management solution will check whether there is a user with the given credentials or not. So that's the process of determining a user's identity. Now each user inside the system will be allocated with different roles or different permissions. Now in order to access a protected resource, the user must have the necessary permissions that the protected resource is asking for. So based on whether the user has the necessary permissions or not, authorization will grant or deny the request to access the protected resource. Now let's see them in action. Now we can divide web API methods into three categories based on how we apply the authorization to them. So first of all, we have web API methods that does not need any type of authorization. For example, consider the endpoints like user registration or sign-in. All of these should be open to anyone without any authorization criteria. And then we have the second category of web API methods asking the basic or minimal criteria for authorization. That is, the user must be authenticated to the system. In case of JSON Web Token authentication, in order to access these types of web API methods, the user must pass a valid JSON Web Token. So this authorization is asking for the minimal or basic criteria. For example, consider a get web API method to retrieve user profile data. This endpoint should be accessible to any authenticated user. And then any web API method asking authorization criteria, anything extra from being authenticated to the system, comes under this third category of web API methods. So the criteria will include role, claim, and policy. We'll be discussing them in great depth. So first of all, I'm going to make a get web API method for user profile, and it should be accessible to anyone authenticated to the system. So back to Visual Studio. First of all, I'm going to create a C# file for account endpoints. Now, like we have discussed in previous video, let's change this class into static. Now, let me add an extension method like we have done inside this identity user endpoints. Let me copy this and pasting the same here. Let's rename this method to map account endpoints. We have already discussed these best practices in previous video. Now we're going to make a GET request, so we can invoke this method map GET, and the corresponding endpoint will be like this, user profile. Now we can handle this request inside this private method get user profile. So here is the method private static get user profile. For now, from this method we'll only return this string user profile. So let's change the return type of this method to string. Now in order to register this endpoint to this web API project, we have to invoke this method from this Program.cs file. So here we go. So here we have a get web API method user profile. From that we are returning this string user profile. Now in order to restrict this web API method to the authenticated user, we can invoke this method require authorization, or we can apply this authorize attribute. Authorize attribute can be applied to the method that is handling the request. Let me build this project. Back to the API Explorer. So here we have the NuGet web API method user profile. Now if you try to access this web API method, you will get this error for node 1 unauthorized, meaning that you are not passing the minimum criteria for authorization, that is being authenticated to the system. So along with making this GET request here, we have to pass the JSON web token that we get from sign-in operation or login operation. So first of all, let's sign in into the application. We have already created a user with these email and password, email@gmail.com. Then the password was string, then followed by #simple. Let's make the request. So here we have successfully authenticated to the system. As a result of that, we got the JSON web token. Let me copy paste the same into Notepad. Now along with making a GET request for this user profile, we have to pass this JSON web token. Now do you remember this illustration from our second last section? Just now we have created a login operation and we got a JSON web token. Now we're going to make a request for accessing a protected resource. So inside the authorization header, we have to pass the JSON web token like this that we have just received. Upon reaching the request at the server side, it will validate the JSON web token, which we have already discussed in our second last section, explaining how much safe is a JSON web token. And we have already configured how this token validation is to be done while adding the authentication service. So inside this extension method, we call this method add authentication, and while invoking this method add JWT bearer, we have configured how we want to validate the JSON web token. And here we have specified what are the schemas that we are using for different handlers inside the identity solution. If there are multiple schemes involved in the process of authentication and authorization, you can set them separately like this. Since all of the handlers inside this project is managed by JWT scheme, we only need to pass the JWT scheme here instead of this lambda expression here. JWT bearer defaults.authentication scheme. Now here we have specified that we don't want to save the token inside the server once the token is generated. And through this token validation parameters, we have specified how we want to validate the JSON web token once it reaches the server as part of accessing a protected resource. So of course, we want to validate the token signature, and for that here we have given the secret key. Now along with this, I forgot to disable the validation of token issuer and token audience. So I will set this validate issuer as false and then validate audience. To explain in simple terms, while creating the JSON web token inside the sign-in operation here we have only passed the user ID. Along with that, we can pass the issuer, meaning the URL of this web API from which we have created the JSON web token, and the audience, meaning the URLs of the client-side applications. So if you want to make sure the issuer or audience that you have passed inside the JSON web token is the inside the receive JSON web token here, you can set this validate issuer and validate audience to true. By default, these boolean properties is having the value true, so that's why we have set it as false here. Now it's time to make the HTTP request to access the protected resource. Along with the request authorization header, we have to pass the JSON web token. For that, if you have an API Explorer other than Swagger, then the process of making the GET request will be much easy. Let me show you how it is done. At present, we are not passing the JSON web token, so let me make the GET request again. Now, let me copy this URL. At present, inside my system, I already have the API Explorer Postman. From that, we can make the request like this. We need a GET request, and here is the corresponding URL. Inside this authorization header, we can set this bearer token. Then inside this text box, just pass the token that we have received. Let me copy this and pasting the same here. Send the request. Boom, we got the success response containing the string that we have sent from the web API method here. Now if you want to see what's happening behind the scene while making this request, you can open this code panel here. Just expand it. See, while making the GET request, inside the header, authorization header, the token is passed here. As a prefix, we have this bearer, just like what we have mentioned here. The same syntax should be used while passing the JSON web token inside the authorization header. You can achieve the same if you have installed the VS Code extension Thunder client. Let's make a GET request, and here is the URL. Inside this auth header, we will select this bearer and we can just paste the token that we have received. Send the request. Boom. Now coming back to our Swagger API Explorer, we don't have a direct way to modify the request header. If you want to achieve the same, we have to do the necessary configuration while adding the Swagger API Explorer inside the project, which we have done inside this extension method. We have to pass the necessary configuration inside this method add Swagger gen. For now, I will just copy paste the configuration that we need for sending the bearer token. So here we go. Here we have the lambda expression with this options parameter. You can copy paste this from our GitHub repository. Let me build this. Now inside the API Explorer, you could see this option for adding the bearer token. So first of all, we have defined a security definition with the name bearer. Inside that, we have set inside the authorization header, we want to pass the bearer token for JWT authentication. And for all the web API methods, we have given a security requirement for the bearer token. And that's the reason why along with all of these endpoints, you could see this log icon. So that's all about configuring the Swagger API Explorer for passing the JSON web token. I'm not getting into the detailed explanation. We are not focusing on Swagger API Explorer. You can just copy paste this code from our GitHub repo. So from now onwards, in order to access any protected resource, first you have to set the bearer token inside this text box here. So let me copy this JSON web token and pasting the same here. Click on Authorize. That's it. From now onwards, for all the requests, the authorization header will be set with the token like we have seen here. Now let's try to make the GET request. Boom. That's it. See how the JSON web token is passed inside the authorization header. So far we have discussed how to deal with the second category of web API methods. Now in any given web API project, most of the web API methods will come under this category. That is web API method asking the minimum criteria that user must be at least authenticated to the system. So in order to avoid repeating this authorize attribute, we will apply this authorize attribute globally across all the web API methods. Let me show you how it is done. For that, back to the Program.cs file. Here we have already added the authentication service into the project by invoking this method add authentication. Now along with that, we have to add the services for authorization. So here we go, services.add authorization. Now in order to set this authorize attribute globally across the web API, we can have this lambda expression with this parameter options. All we have to do is just define a fallback policy. You could think of policy as a criteria. Into that, we have to assign an instance of authorization policy builder. Along with that, in order to set the authentication scheme, we have to invoke this method add authentication schemes. Inside that, we can pass the JWT bearer scheme. JWT bearer defaults authentication scheme. And for all the web API methods, we are asking for the user to be authenticated to the system. Require authenticated user. And we have to finally call this method build. Sorry, we forgot to wrap everything inside curly brackets like this. Now with this statement added here, for all the web API methods, we have set the requirement that the user must be authenticated to the system in order to access any web API method from this project. But there will be web API methods like sign-in or user registration. They must be accessible to non-authenticated users. For that, we can make use of this allow anonymous attribute. So let's see how the web API methods are responding with this statement added here. Let's build this project. Now, by the way, for each rebuild we do inside the Visual Studio, this Swagger UI will get reloaded and the previous JWT token that we have provided inside this authorization header will be lost. So at present, along with any of the requests, there is no token passed inside the authorization header. Now let's see whether we can make the post request for user login or user registration. See, we got the error for node 1 unauthorized. It's all because of this statement adding authorization attribute to all the web API methods. Now let's see how to make web API methods accessible for unauthenticated users. Inside this identity endpoints, we have web API methods for user registration and sign-in. In order to make them accessible for unauthenticated user, along with this method invocation, we can change this method invocation allow anonymous, or you can make use of this attribute allow anonymous. For this entire series, I will stick with attributes instead of methods. So let me remove this and let's copy paste the same attribute for this sign in method also. Build the project. Let's make the request again. See, we are not getting the previous unauthorized error. Now we have to deal with this third type of web API methods. Before getting into that, I want to show you how to retrieve the claims of a signed in user. For example, inside this application, we have already created this getWebAPI method for user profile. Let's discuss how to retrieve the signed in user claims and how we can make use of them. Inside the sign in operation, we have added the payload containing the claims of the user. For example, at present we only have this claim for user ID. As a result of successful authentication, we have passed the JSON token back to the column. And then from there onwards, we will pass the JSON web token to access any protected resource, like we have done with the getWebAPI method for user profile. Now inside the user profile, we want to know how to retrieve the claim that we have added to the JSON web token during the successful authentication process. Now that's the job of auth middlewares. Now like we have already discussed, when we make a request for accessing a protected resource along with JWT token inside the authorization header, before the request reach its destination, the auth middleware will verify whether this JSON web token is a valid token or not, based on what we have configured while adding the authentication middleware. Whatever we have given inside this token validation parameters will be taken into consideration for validating the token like we have already discussed. And when the JSON web token is successfully verified, the auth middlewares will decrypt or unpack the JSON web token into claims principal. Remember, while creating the JSON web token, we have passed the claims inside the JSON web token payload. During the process of verifying the JSON web token, the reverse will be happening. From the JSON web token payload, the claims will be populated with the corresponding values. So in order to access the authenticated user claims inside this user profile web method, we can make use of this claims principal. Now in order to access the same claims principal, we just need to add this parameter here, claims principal. I will name it as user. So the value of this claims principal instance will be injected through dependency injection because of the service that we have added here. Along with adding the authentication services, here we have added the authorization services. It will add a dependency injection for the claims principal. And that's how we are able to access this claims principal inside this web API method. Now we can retrieve the user ID that we have added into the JSON web token during the successful authentication. So here we go. I'll create this variable user ID. Let's access the claims property from the user object. It's an enumerable collection of the claims that we have added to the token. From that we can invoke this method first, and here we have the lambda expression to filter the user ID. X type is equal to user ID. Make sure to pass the same name that we have given while adding the same into the token. And we want to retrieve the value of the claim. Now instead of returning this dummy string here, I want to return the user profile details with the user ID that we have retrieved here. For that, we can make use of the user manager, which is of the type app user. I will name it as user manager. So here we go, user details. From user manager, we can invoke this method find by ID async. Inside that we can pass the user ID that we have retrieved from the claims principal. Since we have an async method here, let's prefix it with this keyword avoid. At the same time, this async keyword will be added to this method here. So we want to change the return type of this method as task iResult. Now let's return the user details inside the response. Results.ok. From that we want to return an object like this. Email is equal to user details dot email. There is a possibility that this user details is null, so I will add this question mark here. Let me duplicate this. Now let's retrieve full name. Let's build this project. Back to the API Explorer. First of all, we have to add the JSON web token into this text box that I will copy paste from this notepad. Now let's make the GET request for user profile. Boom. So that's how to retrieve and make use of the claims of an authenticated user. Now we can discuss the third type of web API methods. Apart from authenticated to the system, these web API methods have criteria defined with role, claim, and policy. Now to discuss the rest of the topic of this video, consider we are creating a web API project for an educational organization. So first of all, we have role. Most often, the organizational designation will be treated as the role. No need to explain much. In whatever organization you are, your role or your designation determines your permissions, your responsibility in the organization. So conventionally, ASP.NET Core Identity Framework has been treating role as a different property to be considered for authorization purpose. Now considering the example project, we could have the roles like admin, teacher, student, etc. And then we have claim. You could think of them as pieces of information about the user. So any information other than the role will be treated as a claim. For example, user ID, which we have already added to the JSON web token, then age, gender, then the class or grade in which the student is studying, then library ID, etc. And finally, we should be familiar with the term policy. You could think of them as a criteria defined with role, claim, and when we want to combine roles and claims, there will be a logic in between them to connect each other. For example, admin only means only the user with the admin role can access the particular web API method. Then we have admin or teacher, female teachers only. All of these policies will be defined and corresponding web API methods will also be created in rest of this video. So without further ado, let's get into it. So first of all, let's look into this user table columns. We have user ID, user name, email, then password, phone number, then full name, which we have added through the app users model here. And rest of these columns are created corresponding to the default properties from this identity user model. Now we have to add columns corresponding to these claims here. And along with that, we have to add the role. As I already told you, the ASP.NET Core Identity Framework already treated role as a different entity inside the identity framework. As a result of that, inside the DB, you could see a separate table for roles. Into that, I will directly add the roles that we have seen here: admin, teacher, and student. In a real-world project, you will be having web API methods to implement the correct operations over the entity role. But in order to save the time, I will directly add the roles into this SQL Server table. So here we go. First of all, we have admin. Inside the normalized name, just enter the capitalized version of role name. Then we have teacher. Finally, student. Now I will show you how to assign these roles to the users that we create during the user registration process. Before that, let me add the properties corresponding to these claims here: age, gender, and library ID. For that, I will modify this model for app user. First of all, we have the property corresponding to the gender. Then we have date of birth, from which we can calculate the age. And finally, we have the library ID. Now, in order to add the respective column into the SQL Server table users, we have to do the migration. So first of all, let's build this project and make sure there is no error. We have a successful build. So open the package manager console. Let's do the migration. Add migration. I will name the migration like added gender, date of birth, and library ID. Finally, we have to execute this command, update database. Back to the DB, refresh the tables. Let's expand this ASP.NET users columns, date of birth, gender, and library ID. Inside this table, we already have 2 users added from previous tutorials. Now for better clarity, I would like to remove those rows here. So here we go. Delete from the table. Execute. That's it. Now let's update the user registration web API method accordingly. So here we have the method to handle the post request for the user registration process. First of all, let's change this model to receive the data that we send through the post request. User registration model. Into that, I want to add these properties: role, gender, age, and library ID. For the sake of explaining this topic, instead of using the date property for date of birth, I have used age. Okay. Now inside the method create user, let's feed the data into respective SQL Server tables. As you already know, there is no property for role inside the user table. So if we want to assign a role from this table rows into a user from this table users, we have this table user roles. The corresponding user ID will be added to this column user ID, and the corresponding role will be added to this column. I will show you how it is done from the web API part, and then we can see how it is added in the respective table. For that, after creating the user, we can assign the role like this. It's an async operation, so I will prefix it with this keyword avoid. From this user manager, we can invoke this method add to role async. As a first argument, we can pass the user object that we used for creating the user. Second parameter should be the role that we want to assign to this user, that we can retrieve from the user registration model role. Now, in order to work with roles, we should add the respective services into this project. Along with adding the handles and stores, here we have added the entity framework stores. So let's add the services related to roles. Here we have to specify the model that we use for roles. We are using the default model from the identity, that will be identity role. For user, the default entity is identity user, but we have customized it into app user. But for the entity role, we have not made any customization, so we'll use the default entity from the identity framework. Now back to the user registration web API method. So this will assign the role passed to this web API method for the newly created user. Now in order to feed the data for rest of the properties while creating this user object here, we can assign the properties
like we have done for other properties here. Gender from gender. Now for the property date of birth, from the current date we are minusing the years as much as age we pass to the web API method. And finally, we have assigned the library ID like this. So this is all the modification we need for the rest of the discussion. Now I'm going to create different users having different values of role and claims. To make the process even more simpler, I'm going to add a JSON file to this project folder directory. Add new item, and I will select this template for JSON file. Let it be user details. Inside that, I will paste an array of objects corresponding to the users that we want to create, so that it would be easy for you to do the same what I am doing here. So first of all, here we have a user with the role admin, and rest of the details are here. Now build the project. Let me copy this object back to the API Explorer, and here we have the post web API method for sign up. For the user we are about to create, there is no library ID. So rest of the properties will be like this. Now click on execute. Boom, that's it. So here we have successfully created the user, and you should see the same in the respective SQL Server tables. First of all, we have the users table. So here we have the new user, and inside this user rows, you should see the admin role added to the new user. See, here we have the user ID for the newly created user ending with C28, and we have assigned the admin role for this user. So this role ID should be the ID of the admin role inside this rows table. See? So that's how this table users rows connect both the entities user and role. Now like this, we have to add rest of the users. So to save time, I will pause the recording of this video, and I will be inserting rest of these users here. Now finally, I'm done with adding all the users. Let's re-execute the select query for users. So in total, we have added 7 users. Now instead of selecting all the columns, let's select only the columns that we really care about. Let's execute the select query again. Let me order the result based on the column full name. From these users' full name and email address, you could know what is their role, what is their gender, what is their age, all of that. So at present, we have 1 admin, 2 teachers, 1 female teacher and 1 male teacher, and 4 students. 2 male students and 2 female students, and out of which only 2 students is having library ID. If you check the user roles table, you could see that all the users are assigned with respective roles. Now you know what we have to do. When any of these users get authenticated to the system, we have to save these information, role and claims into the JSON Web Token payload. Then only these informations will be available for defining authorization criteria. Remember, when a user successfully authenticated to the system, we generate the JSON Web Token. And all the necessary information should be added to the JSON Web Token payload. So whenever we try to access a protected resource with the JSON Web Token, during the process of validating the token will be decrypted or unpacked into the claims principal. And whatever we have inside this claims principal can be used for defining the authorization criteria. So back to Visual Studio, let's update the sign-in endpoint. Inside the method with these 2 statements, we will find and assign the user into this user object if there is a user with the given email and password. Now inside this if clause, we have all the details of the user from this users table. And along with that, we need the role assigned to the particular user. For that, we can do this. We'll have this object roles, and we can invoke this method get roles async from user manager. Inside that, we just need to pass the user object. Since we have an async method, just prefix the invocation with this avoid keyword. Now like we have added this user ID claim, we need to add few more claims. So what I'm going to do is, I will just cut this, and I'm going to assign the same into a variable of the type claims identity as claims. Now we can add the necessary claim. First of all, we have gender, then age that I will calculate from the date of birth. And finally, we have to add the role of the user. Instead of using a string as a key for the claim, we have to pass this role property from the claims type. And here we have assigned the role that we have retrieved here. Now, along with these claims, I also want to add the library ID as a claim. Not everyone has a library membership. So I'm going to do this. If the user has a library ID, we can add the corresponding claim into the payload. So here we go, claims.add claim. Inside that, we can provide an instance of the claim like we have done here. Library ID. From the user, we have to assign the property library ID. While defining this model property here inside the app user itself, you could see that we have defined it as nullable. And for the same reason, you could see this green squiggly line here saying that this property is nullable, so you cannot expect always a value from this property. Since we have added this if clause here, we can ensure that this claim will be allocated with a proper value. So in order to ignore this warning, all we have to do is, as a suffix, we can add this exclamation mark. That's it. Now we can pass this claims identity object claims into this subject here. Let's build this project. Back to the API Explorer. Let's try to log in with a user that we have just created. For that, I will make use of this JSON file, userdetails.json. We only need to copy this email address because this much portion of the email address is given as the password for all the users inside this collection. So here we go. So this is the admin user and here is the password. Let's make the request. Boom. Let me copy the token. Now let's go to the official website for JWT authentication and just paste the same inside the debugger. We have already discussed how to make use of this
interface for debugger in second last section.
Just paste the token here so that you could see what's there inside the payload. See, we have all the claims that we have added from the login WebAPI method. User ID, gender, age, role, etc. So all of these are available inside the claims principle to define the criteria for authorization. Now what I'm going to do is I will just copy this JSON web token and I will add the same along with this object here. I will add a new property called token and let's save the token that we have got with a successful authentication for the user here. It would be helpful to test the WebAPI methods that we are about to create. Now let's see how the payload of the user having the library ID. Let's copy the email address. Here we have the email address and here is the password. Let's make the request. Here is the token. Let's copy this and pasting the same inside this debugger. Boom. Along with other claims, you could see the library ID here. Now let's copy this token and let's append the same to the respective object here. Now like we have added these two tokens for these two users, let me do the same for rest of the users also. It will be necessary for testing the configuration of authorization in various WebAPI methods. So a successful token for every user is added into this JSON file here. Now in order to define authorization criteria with role, claim and policy, I'm going to create a new C# class file for demo endpoints. I will name it as Authorization Demo Endpoints. Let's change this class into static. Now let me copy paste this method for map endpoints. Let's rename this method to map authorization demo endpoints. Let's invoke this method inside this Program.cs file. Now let's see how to define a WebAPI method accessible only for the users having the admin role. So here we go. We have an endpoint admin only. I will handle this request inside this method admin only, and let's define the method here. For now, from this method we are only returning this string admin only. Now if you want to restrict this web API method only users having the role admin, you can do this. First of all, we want to add this authorize attribute. Into that, as an argument, we can pass the criteria like this: role is equal to admin. So whenever a user tries to access this endpoint, the middleware will verify the user has an admin role, else the request will be denied. Let's build this project and let's test the new endpoint. For that, first of all, I'm going to use the JWT token of a student. Copy it and back to the API Explorer, and let's paste the same here. So here we have the new web API method that we have just added. API/admin only. Let's make the request. Boom. We got the error 403 forbidden. Do you remember when you tried to access the second type of web API method here, if you are not authenticated to the system, the response status code was 401, meaning unauthenticated, meaning that you don't even have a JSON web token. Now we got a server response with the status code 403, meaning that you are authenticated to the system but you don't have the required permission to access the web API method. Let me show you that once again. Just clear the JSON web token and just try to access the web API method again. See, this time we got 401. So that's how the status code works. Now let me try to pretend as a user having the role admin. So that will be the JSON web token of the first user. Let me copy this and let's set it as the bearer token. Let's make the request again. Boom, we got the status code 200, meaning everything went successful. And here we have the proper response from the web API method. Next we have to check whether the user is having either admin role or teacher role. So here we go. Let me copy paste this endpoint. The corresponding route will be something like this: admin or teacher. Instead of defining a separate private method here, I'm going to make use of a lambda expression like this. For now, we will just return this string admin or teacher. Now, like we have defined the authorization criteria here, we can add the attribute authorize. Along with admin users, we also need to consider users having the role teacher. That's it. Sorry, instead of adding the authorize attribute here, we just have to give it here as a prefix to this lambda expression. So that's how we can define authorization criteria using only roles. Now if you want to make use of claims or a combination of claim and role, you have to define a policy, meaning a separate criteria should be defined inside the project. That we can do while adding the authorization service. Along with defining this fallback policy, we can define policies like this. Options dot add policy method can be called. Now let me define a policy with this name has library ID. So this is the name of the policy. And as a second parameter, we can pass the condition or criteria with a lambda expression with this parameter policy. All we have to do is we just need to check whether there is a claim library ID. As you already know, inside the users that we have created, there are users without a library membership. So we want to check whether the user is having the claim library ID. We can check that by invoking this method require claim. So we will check whether the user has the claim library ID. Make sure that the same name is used while saving the same into the JSON web token inside this sign-in method here. Library ID. Make no mistake, the same should be provided here. So here we have created a policy or criteria called has library ID. Now we can make use of it while defining authorization criteria. To save time, I will just copy paste the web API method here. So here we have the URL of the web API method, library members only. As the name suggests, this web API method should only be accessible for users having the library ID. So here we have given the authorization criteria with the policy that we have just created, has library ID. Let's build this project. Now let me copy a token of a user having no library ID. Back to the API Explorer, just set it as the bearer token. Since we have defined the method with lambda expression, you could see them under the name of the project, which is Auth API. So here is the newly created web API method, API/library members only. Click on try it out and let's make the request. See, we got the error 403 forbidden because the current user does not have a library ID. Now let's try the same with a user having library ID. Send the request. Boom. We got the status code 200 and we got the proper response from the web API method. Now in order to create web API methods having these requirements, let me add few more policies. Let me copy this and pasting the same below. I will name this policy as females only. So instead of checking whether there is a claim gender or not, we want to check whether the claim gender is having the value female. For that, as a first parameter, we can pass the name of the claim, and then as a second parameter, we can pass the value that we want inside the gender claim. Okay, female. Now along with the gender value female, if you also want to consider other values for this claim, for this criteria, we can pass them one by one after the female value here, like gender 1, gender 2, so on. Okay. Now finally, let me define one more policy for users having the age under 10. So I will name the policy as under 10. In order to define this criteria, we want to check whether the age of the user is less than 10. The comparison cannot be done with these methods here. For that, we'll make use of this method require assertion. Inside that, we can pass a callback method with this lambda expression having the parameter context. Inside this context, we have this object user. Inside that, we have the claims, which is corresponding to the claims that we have added into the JSON web token. From that, we want to check the value of the claim age. So here we go. X time is equal to age, and from that we want to retrieve the value. In order to convert this same into an integer, we can wrap this entire property with this method invocation int32.parse. So this much portion will give us the integer. Now we want to check whether it is less than 10. So here we go. So these are the policies that we need for defining web API methods having these authorization criteria. So let me save this and back to this demo endpoints. Now here we have the get web API method for applying maternity leave, and it is only applicable to female teachers only. Inside this authorize attribute, first of all, we have set the requirement that this is only for users having the role teacher, and they also must satisfy this policy females only. So this is how we can combine roles or policy or claims for defining authorization criteria. Let me build this project and let me copy the JSON web token of a teacher, male teacher, and let's set the same as the bearer token here. Let's try to apply for maternity leave. See, we got the error forbidden. Now let's try the same pretending we are a female teacher. So here is the user. Let's copy this token and let's provide it here. Let's make the request again. Boom. Now finally, I want to define a web API method for females under 10. So here we go. Under 10 females. For that, we have used two policies, policy under 10. So the user must be having the age under 10 as per the policy that we have created here, this policy. And along with that, the user must be having the policy females only. So when we apply authorize attributes separately with the policies, both the condition must be satisfied. So only female users having the age under 10 can access this web API method. Build the project. Let's pretend to be a user having age under 10 but he is male. See, student male having age 9. Let's copy this token. Back to the API Explorer. Let's set the bearer token and let's make the request. See, we got the error forbidden. Now let's try to pretend a female student having age 9. Boom, that's it.
So that's all about this video, guys. In next video, we'll be creating an Angular client for this same web API project. And hopefully we will create one for React also. If you found this video helpful, please consider appreciating the effort through likes and shares. And if you haven't subscribed to the channel, please consider doing it now so that you will get the notification for future uploads. So that's all for now. See you in the next video.